How's your day today? Alex here, and today I'm going to show you something that is technically on the advanced side of C++. We've gone past all the basics you'll need to know to actually program your first game in C++. Now we're moving on to the advanced stuff. So, let me show you a little problem that I want to solve. I want to make a function, let's call it the Alex add operation, because that's what every mathematician calls the new operation. And what this operation will do is it should take a number. Okay, so let's say in num, and then what it's going to do is say num is equal to num plus 3 times 2. So then simple math, very simple maths. Yes, and yeah, that's it. Okay? But I want to keep this as a void for reasons that I won't explain. I want to keep this as a void, but I don't want to just keep it in this function. I want to put it in the main. Okay? Let's make a number. Int x equals 3. Now I want to run the Alex operation on x. Okay? Easy, right? So you already know those functions. And let's see out x. See what happens. And remember, we want to keep this void. And just pause. Oh, great. Okay, so if I run this now, what you'll see is it says 3. But I ran the Alex operation on it. So what should have happened is it should have added 3 and multiplied by 2. So we got 12. So why did it say 3? Well, we ran the Alex operation on it, but we did it when we just edited this num value. We never said, hey, now num should be x. So we never actually changed x to be num, what num was. But I still want to use void. So how do you think we can do this? You're probably telling me that this is impossible. Well, what if I told you there was indeed a way, using what is called a pointer? Let's now ignore the Alex operation and ignore everything here. So we can focus on what is a pointer. Okay, so a pointer is a way of pointing to exactly where in the memory of a computer a variable is located, the exact address. And what that could allow us to do is to use the pointer to edit that variable without actually touching the variable at all. So let's make x again, simple int. And now, here's where things will get a little different. Int star point. Whoa, Alex, what did you just do there? You added a star? This defines a pointer. So now this means that, hey, this point, make it a pointer. But what do we set point to? Well, let's set it to x. Alright, so what happens if I see out point? Well, you can see that there's an error here. I wouldn't actually be able to run this. So why is the error there? Well, we're trying to set a pointer to an integer. Despite being the same, these are actually different. This is an integer pointer, which means that it can point to an integer in memory. This is an integer, which means that it's an integer. So you can't set an integer to an integer pointer. Instead, what we set the integer pointer to is the address of x. This and symbol means address. So if we put this before a variable, we are saying telling C++, get the address of this variable and put it into point. That's what we're saying here. Alright, so now let's run point. What is this? This is absolutely nothing. This is not 3. This is absolutely not 3. Well, this is actually the address of where the variable is. If I were to actually go into where the memory of the computer is and go to this address, I would find x, because it's pointing to the address. Alright, so we know where x is. Let's actually get the value, shall we? To get the value, we have to say star point. This tells C++, give me the address, and then give me the value at that address. If you want it now, 3. Easy, we did it. Nice. That was not that bad. But what we could do now is actually edit point. So by saying star point, which means get the address and then get that value, is equal to 5. Watch what, and get equal to 5. That is equal to 5 now. Okay, of course though, because this is saying see out point. Watch what happens if I try to see out x. Bam. That says 5. But we set it to 3 here, and we only changed it to 5 at point. Because we're telling them what they get the address of the point, get the value, and then set that to 5. And because the address points to x, we're actually this is equivalent to saying x is equal to 5. If that's confusing, trust me, it is confusing, and it gets worse. So you might need to do a little digging around if you're still a little confused. I recommend trying to experiment with these kind of things. But I was confused when I first learned these. But what is the point of a pointer? Well, we can use them in functions. Let's go back to that Alex operation. So we want to keep it a void. And we have, let's just type in the entirety of Alex operation again. That was what it was, right? Yeah. And let's say we have int x equals 3, and then I want to see out x, and then I want to say Alex operation x. Okay? So here we are back at our problem, but now we have new knowledge. We know what pointers are. So let's do a pointer. So what we can easily do is just put a star here. And as you would already know, that means that this is now a pointer, so we now need a pointer. And of course this means we need to change this to a star to say actually change the value, not the address, and actually change the value and actually change the value, not the address here. And then here, instead of passing an x, we need to pass in a we need to actually pass in the address of x, not just x. Sorry. Yeah, so we have to pass in the address of x, not just x. So that now we're passing the address to the pointer, which can now edit the value. So watch what happens. Bam. The Alex equation happened. We added 3 multiplied by 2, and without even touching x, without even returning anything, we managed to change x, all with the power of pointers. Now there is one last thing I want to address, and you might be wondering this as well, depending on what you're thinking. What happens if I create a pointer? So let's just create x equals 3, int star point equals the address of x. But now it's C++. Okay, and then what if I tried to change the pointer itself? So what if I just went point plus equals 2? Well, what do you think that would do? Because you can see that there's no asterisk before a point, which means that I'm saying get the address, but don't get the value, just give me the address. So if I see how points, what the address of point is pointing to here, which will be x, and then the address point will be pointing to here, this is what happens. So you can see that this is the first address, and this is the second address, and we've added 2 to going up to here. The reason it looks weird is because this is actually hexadecimal. But just trust me, we added 2 to this value, and it'll get this value. So we actually changed the location of memory. So what if I just did this? So what if I said, give me the value, and then try to get the value from point to now that we changed the memory? Will we still get x? No. No, we would not. This is x. This is some weird random value. What is this weird random value? I don't know. It could be anything. It could be something C++ keeps in its back pocket, for all I know. So yeah, we could easily fish around the files like this by just adding and subtracting. But you can see by actually doing points, and not by doing asterisks, we can change the value. By putting an asterisk before point, we get the value and can change that value. But by just doing point itself, we can physically change the location in memory it is pointing to. That is weird. And is very confusing. That is the basics of pointers. There are a huge amount of applications that this could be attached to. And if you're confused by this, trust me, it gets worse. There are more confusing topics out there that you will need to learn if you want to really be a master at C++. But I recommend starting here. Start by learning the pointers, and once you think you've got a grasp of them, try to experiment with them in a few different ways. Try different few techniques. And maybe, just maybe, you can start incorporating them in your own project. Once you got that, I think you'll be a master of pointers, and you'll find out how useful they really are. Okay, but that's all you'll need to know for pointers right now, and that would probably be the end of the video. So, if you like this video, you can consider giving it a like, and subscribe to my channel if you want to see more coding videos like this, or if you're more a fan of gaming videos, I have those too. And I'll see you on the next video. Bye.